Hello, my name is Fatih Furkan Erkeç, and in this lab, uh, we check the lab for creating a forecast with Amazon Forecast. In this lab, we will prepare a dataset for creating forecast by using Amazon Forecast, and this lab includes two Jupyter notebooks. One is Forecast Lab, and other is Forecast Autorun. The forecast auto run notebook contains the steps to create forecast by using Amazon Forecast. This notebook run in the background when the lab starts, and it can take between 1-2 hours to complete. And we will refer to this notebook during lab steps, but we won't run any cells. And about datasets, we use online retail to dataset. And attribute information, invoice number, nominal, a 6-digit integral number that's uniquely assigned to each transaction. If this code starts with the letter C, it indicates cancellation. Stock code, product item code, nominal, a 5-digit integral number that's uniquely assigned to each distinct product. Description, product name, nominal. Quantity, the quantities of each product item per transaction, numeric. And invoice date and time, numeric. The day and time when a transaction was generated. Unit price, numeric. Product price per unit in pounds sterling. And customer ID, customer number, nominal, a 5-digit integral number that uniquely assigned to each customer. Country name, nominal, the name of the country where a customer resides. And to complete this lab, we read and run the cells below. And task 1, importing Python packages. We should run this. And task 2, the data is in the Microsoft Excel format. Pandas can read Excel files. And according to the description for datasets, some values are missing. To keep things simple, we will remove anything with a missing value. And start by examining data. We will wait for the code execution. And how many rows and columns are in the dataset? 8 by this number. And what are the data types? We already read that in above. And what does the data look like? It's look like this, row and columns, and the data set is look like that. Amazon Forecast has schema for domains such as retail. Revive the schema information at retail domain in AWS documentation. The target time series is the historical time series data for each item or product that's sold by retail organization. And the following fields are required. And we drop the columns that we don't need. So we drop the other data other than that. And let's run it. The invoice data column is our date time data. We can inform pandas of this by using toDayTime function, and we can explore the data by time by setting the index of the data frame to the invoice data column. We will examine the updated data frame, new number of rows and columns are like that. We drop other rows, other columns, and now new data looks like that. And note that invoice date is the index and it's shown in the first column. This is our index for right now. To select all the rows from a specific date, use the date in the index like that. As we can see, we just seen the data from this date, and we can use parts of date and date range to view the January and February rows. We run 2010 1 and 2010 2, and the date range starts at 2009 and end at 2010 last month. With pandas, we can extract date information easily. We might extract the date information to explore the data further and look for the time-related trends. Extract the year, month, and day of the week, like that. And the data set that we that now have includes purchase made between December 2009 and December 2010. It's reasonable to assume there would be some seasonality in this data. We will now investigate whether there is seasonality, and from this chart we could deduce some seasonality. November and December seem higher than the rest of the year, and quarter 4 seems to be higher than other quarters. For quarter 1, quarter 2, and quarter 3, the last month of the quarter, months 3, 6, and 9 seems to have spikes, and that we have noticed any other seasonal patterns. We can see the lowest is the first quarter, but if we look on average, the quarter 2 is lowest sales, and investigate whether there is any seasonality during the week. And as we can see, Saturday shows very few orders. Why might this be the case? I am not sure, but maybe people don't buy something in Saturday. Cleaning and reducing the size of the data, reducing the countries. Here we can see we have various countries from United Kingdom to Ireland, Canada, Brazil, Korea, etc. And most of the data seems to be for United Kingdom. To make our job easier, we filter the data by United Kingdom. Let's filter it. Because the country column only contains the same value, we can drop it. And now we have a data set like that, and examine stock cut and removing anomalies, and examine the distribution of the stock cut column. And there are 4015 unique values For stock code, a quick plot of the counts might give us some insight into how the values are distributed. As we can see, it seems that there are few high-selling products and with a long tail behind them, and we could investigate this situation further. However, for now, examine quantity. And from initial plot, notice a couple of interesting aspects. There appear to be negative quantities. There are very large spikes throughout the year. Negative and zero quantities could impact the forecast if we don't know why these values exist. To make these things easier for now, we will remove negative and zero quantities. And now examine the price. And the plot shows some clear price spikes. We will now try to find out why these spikes exist. And the stock code value M look unusual, and if we had access to the domain expert, we could learn about importance of M, because we can't ask a domain expert for this lab. We will drop everything in that has a stock code value of M. Drop it. Result is better, but the max value is still high. We will investigate this situation further, and it seems that some adjustments occurred. We will drop also any data that shows these adjustments. And now let's investigate. And we will now examine zero priced items. And there aren't many values in these results, so we can drop zero priced items. Now we splitting the data. The time series data that we need to create a forecast requires a timestamp, an item ID, and a demand. These features will map to the invoice date, stock code, and quantity columns. The related time series data needs a timestamp, and item ID, and a price. These features will map to the invoice date, stock code, and price columns. Create the two data frames. We're creating now, and then sampling. Now we will examine a single item, and we can see multiple orders for each day. We want to create a forecast that predicts demand at daily level, and we must downsample the data from the individual orders into a daily total. And the orders for each day can be summed, because the total demand for the day is the value that we will forecast. Pandas provides the resample function for this purpose. Sum will sum the quantity column. We will also reset the index based on the invoice date value. However, this time it will be date without time portion. It might take up 1 minute to complete. Now I'm going to pause the video here. And now we have this data set, stock code and quantity, and the invoice date. Okay, it gives error because we already run that. Let's wait for that to run. And the order now has a single entry for each day. Repeat this process with the related time series data. We have none values here. Why? The answer is that product had no orders for those days and thus it has no price. Should you fill these non-values with a numerical value? We can pad to. Should we? I think we shouldn't, because it could affect the forecasting. And we can use path to forward fill the price. The previous value will be used to fill the gap for each missing value. So yeah, we are filling. I assume wrong. And we can use path for missing values. Now we can see there is no non-values. Reviving the creation of forecast. The following cells are marked down. They demonstrate the API calls that are needed to create a forecast based on the data that we have been working with. Creating a forecast with Amazon Forecast involves 3 steps. 1. Creating a dataset and importing the data. This process typically takes 5-10 minutes. Creating the predictor. This process trains a model by using the data that we provided. It takes 30 to 60 minutes to complete. And creating forecast. This process generates a forecast for a particular item by using the predictor. It also takes 60 to 30 minutes to complete. To save time when this lab has started, the forecast author on IPMB was also run in the background. The notebook will be updated with the results after running completes. It takes about 65 minutes to run, but it might take a little longer. By the time we revive this cell, the forecast creation should in process. While it's finishing, we will revive this code. Feel free to revive actual forecast author on IPMB this code if you want some more detail, or make sure that you don't run any cells. So creating the datasets and importing data. The first step is to create forecast data group. We create dataset function require FF parameters. Creating forecast dataset groups in here. And domain dataset type, dataset frame, data frequency, and schema is parameters. And the dataset schema for the time series data is schema attributes, attribute name, attribute type, attribute name, attribute type. We are going like that. The goal to create the dataset is time series response forecast create dataset and domain retail and dataset type target time series dataset name retail time series data frequency and schema. Now the dataset is defined, a job is needed to import the data, and this import job response forecast create dataset import job. We create the dataset import job here. We defined, and note that the data source is a path to the data that's stored in Amazon S3. The final step is to add the dataset to the dataset graph, and the process of adding the related data or metadata is done in the same way by changing the name, schema, and dataset type. Although we have prepared this data, we won't use it in the predictor because the model wasn't impacted by the additional data. So creating the predictor, the next step is to create the predictor. Command name is parameters, predictor name, algorithm arm, evaluation parameters, forecast horizon, input data config, featureization config, and this parameter specifies the name that we want to give the predictor, and this parameter is the path to the algorithm that we want to use. In this example, we will use deep AR plus, and this parameter enables you to specify the number and size of the back test windows. Recall from module that this parameter controls the size and number of testing windows that are created from the data. This parameter, how many units to forecast, in this case the units are days. So this parameter specifies the data along with optional vacation days. This parameter sets the frequency, but it can also be used to specify following methods for data. The code to create predictor is like that. After the predictor is created, we can create a forecast. To create a forecast, use the create forecast method, and we define predictor earn, create predictor response predictor earn, and we use create forecast methods in here. After the forecast generated, the results can be queried by using query forecast methods. And task 5, the forecast should now be created. You can investigate to see whether the forecast creation is complete. First, create a helper method to show the status. Next, create instance of the forecast and forecast query objects. You will read the variables from the store and check whether forecast was defined, and the forecast, after the forecast is defined, you will wait until its stats become active. Okay, so now we will wait for it to be finished. I'm pausing the video here. The process is finished right now, and in task 6, using the forecast, at this point there should be a forecast that ready to be acquired, and check that you get data for the following stock code 21, 23, 2, and plotting the actual results. Earlier we split the data and held back the November and December values. We will plot these values against the predicted values for the same period. We will start by reading test values back into data frame and check that we only have data for the 21, 23 to stock code, and we can do a quick plot of the data. Remember, this data, this test data, this is the test data, so actual values are plotted. In the next step we will plot predicted values. They don't predict any, I don't know why. Let me run these cells again. Maybe about that zero quantity we have an error. So let's continue plotting the prediction. Next we must convert the JSON response from direct predictor to data frame that we can plot. Start by getting p10 predictions. Now we plot the p10 predictions, and the previous code only retrieved the p10 values and put them in a data frame. Now complete the same process with p50 and p90 values. And comparing the prediction actual results. After we obtain in data frame, the next task is to plot them together to determine best fit. Import observed values into data frame. Again, we getting no data. I don't know why. Timestamp value. But let's run it. And creating a pivot on the data, we can compare the actual P10, P50 and P90 values. And charts can be easier to analyze than the raw values. Yeah, charts here. And green is P90, orange is P50 and blue is P10. Examine the results and cleaning up. The following cells will clean up the results that we were created during this lab. Okay, we clean the results we created during the lab. So that's it for this lab. Thank you for watching. Have a nice day.